Every project car eventually hits the same wall. You need a part that's impossible to find. So that's when I turned to 3D printing.
So we're going to cover 3 different ways on how to make your 3D printed car part. One is through a quick edit. The second way will be through simple CAD. And the third will be using a 3D scanner. That way you can get a factory OEM plus finish that fits perfect the first time. So here's the first part that we're going to be remaking. It's plastic and it has a few broken clips, which makes it a perfect candidate for 3D printing. The part does go up right in the corner of our BMW E30 project in the corner of the window. So that means we're going to have to make it out of something durable and that can handle a little bit of water. So the filament of choice that we're going to be using is ASA filament. It can handle up to 220 degrees Fahrenheit, is UV resistant and water resistant too.
Now the first thing I did was search for the part, and with a bit of luck, someone else already made it. So I downloaded it, threw it into our 3D printing slicing software, and flipped it on its flattest surface. I'm also going to print it with some spare gold PLA filament to make sure that the part comes out the way we want it before it's printed in ASA filament.
So this is how the prototype came out, and I actually like the additional tweeter design. This is by EME Motors, so props to him. But the only thing is I'd like to create a cutout for this because cutting it manually just won't look as good. Don't ask me how I know. And also these tabs can be just made a little bit stiffer.
So now I'm going to show you the first way to quickly edit the file right in your 3D printing software. And that's by right-clicking the model, select Add Part, and I'm going to use Select Cone. This is an extra part that will be infilled with material, so I'm going to drag it over the clip and change the size, which will give the pin some more layer adhesion at the base. And with a copy, I was also able to add the same part to the other clip as well. Next up is to make a cutout for the tweeter insert. You can do that by adding a negative part using a sphere. Resizing and moving the part around like this takes a bit of work, but for very small modifications, you can make it somewhat doable. Now all we have to do is select the right printer and filament. We'll be using black ASA filament, but there's one more thing that I want to try. This time I'm going to add a modifier and select Cube. The modifier will let you highlight a part of the print and apply specific settings to the part that the cube touches. And the feature I'm going to turn on is Fuzzy Skin Contour, which is going to give a little shake while the filament is extruded, giving us a nice texture to our part. Here's how the final part came out with the updates. The clips have a much stronger base from the extra filament. The cutout looks great, and the fuzzy skin gave the entire part a nice textured finish.
But what if you needed to make more precise updates with a file you found online? Well, that's where CAD comes in, but don't worry, it's not going to be overly complex CAD that takes you 30 days to learn. Trust me, because I spent weeks looking for the perfect CAD software program that can get you up and running and making parts in just one day.
And the software we'll be using is Shaper 3D, and it's also supported on the iPad and Apple Pencil. You can import STLs like the original tweeter we found online and change the opacity. This will let us recreate the part or reverse engineer the original design by drawing the sketch over the imported STL. Once the sketch matches the original part, we can use the extrude function. I was also able to recreate the tweeter design and modify it to different dimensions, or you could get rid of it altogether and make the part completely flat. And if you need help learning how to reverse engineer your own parts, I have an entire workshop that covers the full process, which I'll leave in the video description below.
But what if you needed to make a file that you couldn't find online, like this plastic relay cover? The only additional steps that you'll need are to measure it, so that way we can sketch it out in Shaper 3D.
Any ruler will do, but I like using a digital caliper tool, which makes things really easy for grabbing the dimensions. And I also like to sketch my part on paper from different angles while I grab each measurement. This will make the next part much easier to design. Now that we have our measurements, we can sketch the part in Shaper 3D, and all we have to do is extrude the main body, hollow out the part, and draw the rest of our shapes. I also sketched this BMW logo and extruded it by 0.2 millimeters. Then we can export the file as an STL and drop it right into our 3D printing software. I'm also printing the part in red ASA to give it a nice contrast in the engine bay, and you can see that the 0.2 millimeter extrusion is just enough for the logo to pop through the bottom of the design. And here's the new part hot off the printer. The red ASA gives the part a pop of color, and the logo design is visible from the printer, skipping the first layer where the sketch was extruded. But the real question is, does it work? A perfect fit. Here's the old part and the new side by side.
So for our next part, it's a little bit more complex, as you can see. It's a bezel that goes over our cluster gauge, and it has a bunch of these different curves. Now, we could try remaking this manually by trying to come up with the measurements and the curve, or we could just 3D scan it.
Scanning will make reverse engineering the design in Shaper 3D much easier. And to prevent the scanner losing track of the bezel, you definitely should use tracking dots. Once the scan was completed, I deleted the parts that we didn't need, and here's what the final mesh looks like. Now we can export the scan as an STL. From there, we can import the STL into Shaper 3D and start to reverse engineer the scan in sketch mode. The basic shapes can be traced with the line tool, and I added a few reference lines to map out the center. Then I used the spline tool, which lets you adjust the curvature on each point to match the outer shape of the scan. And instead of trying to create the same curve again, I used the mirror tool and used the center reference line to copy over the curve. Now that the entire outer shape is copied, I used a few more tools to trace the design, then I extruded the different sketches that were created to match the basic shape of the scan. And after a few final touches, this is what we're left with. And if you want to learn reverse engineering in detail, I also have an entire module with other examples in the workshop as well. Now all that's left is to export the design as an STL and import it into the 3D printing software. I'm using the Bambu Lab H2S because it has a big enough build plate to print the entire part, and all we have to do is change the position. This lets us print the entire part flat on its base. I'm also going to use red ASA to match the fuse holder, and don't forget to enable supports to hold up any of the overhangs.
All right, this thing is freaking sick. Take a look at that. Printed out on ASA red filament, and here's the original. So kind of beat up, rough around the edges. We've got the mount points. It's got the slight curvature in the back. Now the front doesn't have the curve, and I did that intentionally just to give it a bit more of a different look. I don't know, what do you think? Original, 3D printed. And it's also going to match our relay cover, the red relay cover, with this nice red accent. And if you want to learn more about 3D printing and design, watch this next video right here.